Today we'll delve into the Swish activation function. In neural networks, activation functions determine the output of the neurons. A neural network without an activation function can become just a linear regression model. Enter Swish. Proposed by researchers at Google Brain, Swish is an activation function that aims to resolve the shortcomings of the traditional ReLU function. ReLU, or rectified linear unit, has been the go-to activation function for a long time, but it comes with its own set of limitations, like the dying ReLU problem, where neurons become inactive and only output 0. Swish calculation is simple. It's just the product of the input and the sigmoid function of the input. In simpler terms, Swish takes the input, passes it through a sigmoid function to squash its value between 0 and 1, and then multiplies the result with the original input. Unlike ReLU, which has a sharp corner at x equals sine 0, Swish is differentiable everywhere. This smoothness can help in improving the optimization process and the stability of the gradients during training. Swish is a non-monotonic function, meaning it allows for negative outputs. This property can be beneficial in certain scenarios where the network needs to learn more complex and non-linear relationships. The non-monotonicity of Swish allows it to capture both positive and negative relationships between the inputs and outputs. Swish has been shown to outperform ReLU in deep neural networks, particularly in models with a large number of layers. The smooth and non-monotonic nature of Swish helps in alleviating the vanishing gradient problem and allows for better training of deep architectures. Experimentally, Swish has demonstrated improved performance compared to ReLU on several benchmark datasets and tasks, such as image classification and machine translation. However, the performance gains may vary depending on the dataset and the network architecture.